Hi everyone, welcome to your Homework 1 solution video. What I'm going to be doing today is go through each and every sum for Homework 1 and I will solve them as we go along. So you will get an opportunity to see how I approach my problems and write my code, and you'll also be able to compare my code to yours. If you have any questions about how I'm solving the problems, please feel free to drop by our office hours and we can help you out. All right? So I have my MATLAB grader, which is open to the learner preview. So this way I have my question here, the script here, and all the assessment variables right here. And I also have my MATLAB software application open. I have split the window into editor, workspace, and command. And I'm remembering to always code using my editor window. The first thing I'm going to do is save this file. And I like to save my files with the name of the module or the question I'm doing. So this is homework 1, question 1. And I also like to add something so that it'll be easy for me to go back and look into this if I'm trying to find this problem. So I'm going to say operator precedence. All right. Okay, so now that I have that saved, I am going to start with my question. Again, before I start solving this question, I want you to keep in mind this particular page of your notes. So page 30 of your notes, there's an example of how to write a code to check if x lies in between 5 and 10. If yes, 1, otherwise 0. So when you look at the answer, the correct way to do this is this statement. So you have your first condition, you have your second condition, and they're joined by the AND operator. This is the way to approach any problems that asks you to check if a particular number is between two different conditions. Why the second statement will not work is because both of these operators are the same, therefore, and have the same precedence. Therefore, the expression is going to be executed from left to right. When this happens, the first half of the equation, so 5 is less than x1, is going to be evaluated first. Given that x1 is 6, the answer of this is going to be a logical value 1. Then the rest of the expression will be evaluated. But instead of comparing 6 with 10 as it should, MATLAB is going to evaluate the logical one with 10. So although 1 is less than 10 and the final value is going to be true, this is not the right way to approach the sum. All right. Keeping this in mind, we're going to start with our homework 1, question 1. I am going to copy this snippet which has been given to us in my MATLAB window. This right here. I'm going to kind of reduce the command window because I'm not going to be using it for this question. All right, so let's see part A. Write a code to check if x plus z is greater than y and less than y plus 5. If yes, assign true to LGA and otherwise false. So I'm going to write a comment so I know I'm solving for part A. The next thing I'm going to do is figure out the first condition. So I need to check if x plus z is greater than y. All right. So my condition A1 equals x plus z, is greater than y. Now I need to figure out my second condition, which is this. Less than y plus 5. What is less than y plus 5? X plus c, right? So that is going to be my second condition. So con A2. All right. So x plus c is less than y plus 5. Now that I have my two conditions, I'm going to see what my question needs. It needs me to assign true to LGA. So I'm going to write my variable, which is LGA. If x plus c is greater than y and less than y plus 5, this and is the keyword here. So because I need both my conditions to be satisfied, I'm going to be using my logical operator and. So this is going to be condition A1 and condition A2. And that's the answer for part A. Great. Moving on to part B. Write a code to check if x is greater than 6 and less than 12 and is not equal to y. All right, so let's figure out the conditions for this particular question. What is the first condition? It is if x is greater than 6. So I'm going to write that down. X is greater than 6. Okay. The second part of the condition is if x is less than 12. So let's get that on here. And the third part of the condition is if x is not equal to y. Therefore, the not equal to operator is a combination of your not equal to y. I'm going to add spaces on either side just so that it's easier to read. All right. So these are my three conditions. And how would I join these three conditions? Let's read the question again. So x is greater than 6 and, which is a keyword, less than 12 and not equal to y. So the way I'm going to join these three conditions is LGB. I'm mentioning LGB because that is what the question asks me. If yes, assign true to LGB. So LGB equals condition B1 and condition B2 and condition B3. All right, so this is my question 1 part B. Moving on to part C. Write a code to check if x is greater than 5 and less than 10 or is less than y plus 5. Again, let me write out my three conditions. So condition C1, x is greater than 5. Condition C2, oops. My condition C2 is x is less than 10. My condition C3, if x is less than y plus z. So x is less than y plus z. All right, so I have all my three conditions laid out, and now I'm going to read the question again. So x is greater than 5 and less than 10, or this is a new one, is less than y plus z. All right, so how my conditions need to be connected is I'm going to look at the variable I need to store my answer in, which is LGC. So LGC equals, so the first and the second conditions, right? So condition C1 and condition C2. But there is an or in between the two of these. So I'm going to use the or operator. Condition. I did not add any brackets to these because the question does not mention any preference in solving any of these particular conditions. So I will just go exactly like the question says. X is greater than 5, which is condition 1, and less than 10, which is condition 2, or less than y plus z, which is condition 3. Moving on to part D. Okay, so part D mentions write a code to check if y plus 3 is greater than 6 or less than z or equal to x plus z. All right, let's lay down our conditions again. So this is condition D1. Says y plus 3 is greater than 6. Condition D2 equals y plus 3 is less than z. So now I have a new thing. It's y plus 3 is equal to z plus x plus z. How do I check for equality? Using the equality operator, which is a double equal to sign. So it's this, all right? And this should be equal to x plus z. Okay, so I have my three conditions laid out. Now all three of them are separated by or, and there is no preference given to either of them. So I'm going to write, what do I need to assign it to? LGD. So LGD equals condition D1 or condition D2 or condition D3, right? And I'm done with my part D. I move on to my part E. Write a code to check if x times 5 is less than x to the power 2 and is not equal to z. If yes, assign true to LGE. So this question I have only two conditions, which is great. So I'm going to write my two conditions. Condition E1, which is equal to x times 5. So I'm going to put that in brackets, x times 5. Please remember to put the multiplication sign because MATLAB needs the multiplication sign to multiply two numbers. You cannot just write 5x. All right. And this is less than x to the power of 2. All right. The next condition is condition E2, which is if x times 5 is not equal to z. So we're again going to use the not equal to operator. All right. So here, x times 5 is not equal to z. Perfect. So I have both my conditions and I need to join them using the AND operator. So this is going to be LGE equals condition 1 and condition E2. Perfect. So I am happy with all my equations and my code, and I'm going to run this. All right. So I can see on the command window that it's running properly. There are no errors. I see in my workspace that I have all my numbers. I can check for everything, and I am going to now copy paste this code. Please remember not to include the x, y, and z, which are already added to the script again. All right. So what I'm going to do is take all of this, copy it, come here and paste my solution. Perfect. Now I'm going to run my script. Okay, the code ran without output. Yes, I have not printed anything in this equation. So now I'm going to press submit. Perfect. All tests passed. And we're done with our homework 1, question 1. Everyone, we are now starting with the homework 1, question 2 solution for Riemann-Roch function. All right. So I have my MATLAB Creator window open right here, and it is set to learner preview. So I see exactly what you see when you open MATLAB Creator. And here I have my MATLAB software open with the editor window, the workspace, and the command window. So the first thing I'm going to do is save this file. And I'm going to name it something easy so I can come back to it and refer to it whenever I want. So homework 1, question 2, and I'm also going to add a little hint so I don't have to look through multiple files later on while looking for this question. Riemann-Roch, all right? And please make sure your files are all saved in the .m format because you need this to be able to open your file later on. Okay, save. All right, so let's start the question. Kasturi is working on a project where she measures the daily average temperatures in degrees Celsius for Waterloo, Kitchener, and Cambridge. These values are stored in the variables x, y, and z. Okay, so if I scroll down to the script, I can see that I have already been given the values of x, y, and z. So I am just going to copy those and paste them right here in my editor window. All right. Okay, so now what is x, y, and z? So it is a random integer value drawn from the interval minus 50 to 200 and then divided by 10 to obtain a decimal value. All right. So my x, y, and z values range between minus 5 and 20 because they're randomly generated values between minus 50 and 200 and they have been divided by 10. So this way I have a range of decimal values between -5 and 20. Also keep in mind that x, y, and z are variables of the double data type, because any decimal or number values are always stored in the double data type. So right now, if I write class X, I would get double as the answer. Okay. All right. So the first part of the question is the nearest integer temperature values for X, Y, and Z stored in variables X1, Y1, and Z1 respectively. So the question asks me to store my values in variables named X1, Y1, and Z1. So if you remember from the first half of your notes, where we learned the assignment statement, so any variable to which you're assigning the value of an expression will always come on the left-hand side. Okay, so I'm going to go here, enter. So my X1 is going to be on the left-hand side, and then I'm going to write an equal to sign. So what do I want X1 to be? It's the nearest integer temperature to the value of X. If you look back at your notes and you go to page 32, you will see that we have gone over a bunch of different functions that help us to round numbers, and all of them have different properties. So for the first part of the question, I need the nearest integer temperature. I'm going to look through all of these functions, and I see that rounds x to the nearest integer. So I think this is the function I need to use for this particular question. Therefore, I'm going to write x1 is round x. Similarly, y1 is also the nearest integer temperature to y, and z1 is the nearest integer temperature to z. I am going to replicate the statement for y1 and z1. Make sense? All right. Now we move on to the next question. The nearest integer value greater than or equal to temperature x plus 5 divided by 2 stored in a variable named x2. Before I start that, I'm going to write a small command here so that I know this is the solution of part A, and do the same for this so I know this is the solution for part B. All right. So I need the second part of my solution to be stored in a variable named x2. So I'm quickly going to write x2 to the leftmost side of my expression. And now I need the nearest integer greater than or equal to the temperature x plus 5 divided by 2. So I know that the variable that's going to come within these brackets is x plus 5 divided by 2, because this is my new temperature value, right? To get a nearest integer greater than or equal to, I'm again going to revisit this page. Out of all of these functions, I feel that ceil is the one that rounds x to the nearest integer towards positive infinity. Since we're going towards positive infinity, the rounded value will always be greater than x or equal to if x itself is an integer. Therefore, for this particular question, I'm going to be using the ceil function. So here I would write ceil, and in brackets I would write x plus 5 divided by 2. Alright, why did I put these brackets? Because according to operator precedence, if I had not put these brackets, the 5 divided by 2 would have been performed first, and that's not what I want. According to the question, it's x plus 5 within brackets, which is divided by 2. So this operation needs to be performed first, right? Okay, moving on to part C. The nearest integer towards 0 to temperature y minus 3 stored in a variable named y2. So now I already know I need to write y2 at the beginning. This is the variable in which I'm going to store my value in. The nearest integer towards 0. Let's check the notes again. Out of all of these functions, the one that truncates x to the nearest integer towards 0 is fix. So I'm going to be using the fix function. Fix, and it is y minus 3. So y minus 3. Moving on to part D. All the nearest integer lesser than or equal to temperature Z divided by 4 stored in a variable named Z2. So again, as usual, I'm going to write Z2 and then think about my function. So here I need the nearest integer lesser than or equal to. Checking my notes again. So floor is the function that rounds x to the nearest integer towards negative infinity. So if the rounding is going towards negative infinity, it's always going to be lesser than my integer value, than my variable, or equal to the variable value if my variable is already an integer, right? So it satisfies the question. It satisfies nearest integer lesser than or equal to. So I'll be using the floor function here. And what is my variable? The temperature is Z divided by 4. So I'm going to write Z divided by 4. All right, perfect. So I'm done with the first 4 parts of my question, and now I'm going to move on to part E. So part E says, she also needs to know if x1, y1 and z1 are even or odd temperature values and store the answers in variables lgx, lgy and lgz respectively. So first of all, I'm going to write lgx right here. Okay. Reading the note, it says, variables lgx, lgy and lgz being 1 indicates an even temperature value, whereas 0 indicates an odd temperature value. Alright, so let me think about this. How do I know if a number is even or odd? The simplest way is to divide the number by 2, and if the remainder of this division is 0, that means my number is divisible by 2, and that means my number is even, right? So what is a function that gives me the remainder? So scrolling down, I see the rem function right here on page 36. It computes the remainder of x divided by y, and the syntax for rem is rem x comma y. All right, so I am gonna quickly write, so lgx corresponds to my x1 value. So I'm gonna write rem x comma 2. But what is this gonna give me? This is gonna give me, oh sorry, this should be x1, I guess. Yes, x1. Okay. What is this gonna give me? This is gonna give me the remainder when a number is divided by 2. So say my x1 is an even number and I divide it by 2, my remainder is gonna be 0, right? And that's what this is gonna return me. However, when I read the question, it says the variable lgx being 1 indicates an even temperature. So how do I ensure that this lgx would have the value 1 when my x1 value is even? So when I think about it, the trend between all even numbers is the remainder is always equal to 0 when that number is divided by 2. So what I would do right here is use the equality sign and say 0. I'm just going to give some space so that it looks better. But yes, so this is my solution. lgx equals rem x1 comma 2 equal to 0. Makes sense? Okay, and this is the exact same thing I'm going to do for lgy and lgz. So I have y1 comma 2 equal to 0, and lgz equals rem z1 comma 2 equal to 0. All right. And the last line says x, y, and z values have already been provided in the question, so please do not generate or change any values in x, y, and z. Okay, so the first thing I'm going to do is run this question. Okay, it runs perfectly, and I have all my answers. Okay, let's check it. So my x value is 15.4, and my x1 value is 15. Yes, it is perfectly rounded to the nearest integer. My y value is 17.7 and it's rounded to 18, which is the nearest integer. My z values is minus 1.9 and it's rounded to minus 2, which is the nearest integer. So my A part is correct. Looking at my B part. So this needs to be x plus 5 divided by 2. My x value is 15.4. So x plus 5 would be 20.4 divided by 2. That would give me 10.2. All right. So the CL value for 10.2 would be 11. And that's exactly what it is. Perfect. For fix, so y minus 3, y is 17.7. So it's 14.7 is my y minus 3, and fixing it should give me 14. Perfect. And the z value is z divided by 4, and the floor value for the same. Where is my z value? My z value is 1.9. So 1.9 divided by 4 would give me 0.475. So minus 0.475. And flooring that should give me minus 1. Yes, that's exactly what it is. And now I have my x1, my y1, and my z1. So I can see x1 and x1 is an odd number. So LGX is 0. Y1 is an even, LGY is 1. And Z1 is even 2. So LGZ is 1. Perfect. So I'm happy with my solution. I am going to copy this right here. Go and paste it right here. All right. I'm going to run my script. Code ran without output and submit. Perfect. And now we're done with this question.